Okay, so welcome back. This is part 4 in our series where we're helping you to understand what are relays and how do they work. And in part 1, we gave a general overview of protective relays, and we said that those are used virtually everywhere around the world in industrial, commercial applications, and in fact, the power lines that feed your home or office are protected by protective relays. And their job is to monitor the electric circuits continuously. And when they sense a problem, they will generally start a timer. And if the problem still exists after the timer times out, they will perform some action. And generally that action is to open a circuit breaker to de-energize the power feeding your home and your neighborhood so that it can be fixed and then the power is restored. So in parts 2 and 3, we started to develop this application here, which is a relay simulator. And we're writing it in C# Windows Forms Visual Studio. And as I mentioned, I really encourage you, if you want to understand a scientific or engineering concept, it's a good idea to actually sit down and spend the time to write a simulator. Because in order to write a simulator, some code like we have here, you need to define to the computer exactly how the thing works under the hood. So it's a great opportunity to learn. So in parts 2 and 3, we started to build some code to define various aspects of this relay simulator. Part 2, we talked about making a relay class in C# that defines the overcurrent relay that we're modeling here. And in part 3, we added some more functionality, which is called a digital fault recorder, which I'll show you the functionality here in a bit. It basically monitors the system, and when, in this case, the current exceeds a certain value, it records it so that somebody can take a look and see what was happening. So I encourage you to look at those. Now in this video, we are going to try and pull all of that together and show you how to write the user interface code that you see here to give you this functionality. Now in other videos, we have talked about some components of this. For example, over here, where the user can select the curve type for the overcurrent relay, there's 3 radio buttons. We recently did a video on how this works and how you can set this up. We also talked about what you see here, which is circuit breaker open-close indicators that change depending on the status of the breaker. And we're using a picture box with multiple images. We talked in a recent video about how to do that, and also with this fault indicator. We also had a recent video where we talked about what you see here in the middle, this rich text box, which is intended to simulate kind of an LCD display. And we did a recent video on how to set that up. And we also did a recent video on the digital fault recorder class. And as you'll see in a bit, the purpose of this was after we've had a fault, we press this button and it brings up another form which has a chart that shows you the chart. And we also did a recent video on multiple forms and how to do that. So I encourage you to look at that. So let's start this out and just show you what we've got so far, and so we can show you how to implement that in the UI. So we're connecting to our bench equipment here over a COM port, and we can make a connection to the COM port, and we've got an Arduino with a current sensor we talked about previously, and now we're pressing the start button to start the simulation, and it's measuring 0 amps coming from our power supply via the Arduino. So now I'm increasing the current coming from the power supply, and you can see that the relay has started timing, and we got a flashing light. And now that it's timed out, we can take a look at the DFR functionality. So you can see in our rich text box, we've got a different font showing it took 11 seconds to trip the relay. And we hit the DFR functionality, and we get a separate form that comes up. And again, I encourage you to take a look at how we do that in a separate video. And you can see it shows the current over time to the point where the relay trips, and we can close that. So let's take a look at our Visual Studio solution and see how we can bring all this together. So here we are in our Microsoft Visual Studio C# Windows Forms application. And you can see I've got our Form 1, which is the main user interface. And again, I've talked about some of these components in previous videos. If you don't understand any of this, how to do it, look at my previous videos. I've even got a C# for beginners 3-part series if you want to learn how to write software. But here's our main user interface. And I've also got, for our digital fault recorder, I've got a form 2, which is a separate form. And it's just a simple form with a chart and a close button. Again, we talked about this in a previous video. Now on the main form, as you can see down here, I've drag and dropped a system timer, which is going to run the simulation, and it's going to be doing most of the work. And I've also drag and dropped a serial port onto this, and I've named it Arduino port. So the way this is going to work, the system timer, timer 1, is going to, every time step, it's going to call our overcurrent relay and our digital fault recorder and tell it to do its job and then move on to the next one. So it's all going to be run by this system timer, as happens with many software simulators. So let's take a look at the Form 1 code. Here I've got the simple Form 1 code, and as I usually do, I separate it by regions into documentation, properties, here's the main Form 1, and then methods and event handlers. First we'll look at the properties. The first thing I do is I instantiate a overcurrent relay class and the DFR class we talked about previously. Overcurrent relay, relay 1, and this takes some values in the constructor. We've got a curve type 2, we've got a time dial of 5, we've got a pickup amps of 2, and then an ID of 1. And then we're instantiating the DFR class, and it takes no parameters in the constructor. Now we have a double called Arduino VREF, and I did another video. If you use an Arduino, this is really important that you understand this. In this case, I have measured the actual reference voltage the Arduino is using based on the voltage it gets from the USB port. Not 5 volts, 5.18 is 1023 for the Arduino. So I did a video on what this all means. I encourage you to take a look. If you don't do a correct VREF in this application in particular, you're going to get some very bad current readings. So you need to understand how that works. Sensor amps per volt. I did a video on the CZH current sensor we're using, and it assumes 10 amps for every volt that it gives into the Arduino. I've got a double fault start time. I've got a double filter amps. If you are familiar with the Arduino and measuring input analog values like this, the results will be, we're going to be measuring every about 1/10 of a second, and the values we get from the Arduino are going to bounce all over the place. So what I've done is I have, and we'll see this in a bit, I've included what's called a low-pass filter that I've talked about in other videos that kind of filters the incoming readings from the Arduino to smooth it out a bit and not make it so messy. So I'm starting out with a filter amps of 0 and a filter amps old of 0, and we'll see how that works in a bit. I've got some booleans. Is the fault started? Start out with false. Did I do a trip output? False. Is the fault indicator, this flashing fault indicator, that's not on. And then I've set up a string log file path. What I'm going to do is when I'm done, when I get a fault and the relay trips, it's going to automatically send out the DFR data, the time and current readings, to a CSV file. So this is just the path. And then I've got an integer called flash delay equals 0. When we initialize the form, we've got some stuff here. We are setting the timer 1 interval to whatever is in this SCADA class. And the SCADA class has basically 3 values we talked about before, but these are available to everybody because it's a public static class SCADA. So the sim time seconds, we're going to keep updating this every time step. The time step milliseconds, we're saying we're going to have 100 milliseconds or 1/10 of a second time step. And then the line amps is going to get updated every time step. So as the current coming into the Arduino from our bench equipment, that's going to change every time step. We're setting a time step interval, whatever that time step milliseconds is. And now we are setting some defaults for the UI. You can set whatever you want here. The COM port, we're defaulting it as COM6. We are setting the radio button 1, which is this radio button, we're setting it to an inverse curve default. We are setting minimum trip as 2 amps, and we're setting the time dial as 10. You can put whatever you want. And then we are disabling some buttons that aren't available yet. The start button, we can't enable that until we have opened the COM port, so we're setting that enabled false. Stop button, false. DFR isn't available yet, so we set that to false, and then the COM port close is false. And now we're going to go to the event handlers. And of course, the first thing we're going to do is open the COM port, and we've got some code here we've done many times in previous videos. We're just setting the COM port name as to whatever's in the COM plus COM6. Here I've added a this.activeControl equals null, because when we start this up, this COM port text box, it highlights the number, and this is just to clean that up so it doesn't highlight the number. So I've set it to null to make sure it doesn't select anything on the UI. And then we try to open the COM port. If it doesn't work, we've got a message box show. Dude, seriously, you need to plug the device in first. We've done this many times before. And if the COM port is open, then what we do is we set the status to open in this text box. And then we basically set some other UI stuff. We set the COM port close. We enable that. Since it's open, now we can close it. And we change the color so it's now available. And then the COM port opens. Since we just opened it, we disable it. And now that we've opened the COM port, we can now start the simulation. So we go to the button Start, click. And what this does is, depending on how the user has set these values for the particular overcurrent relay, the curve type, minimum trip, and time dial, we're going to set those values to what's appropriate. So we have, if the radio button 1 is checked, then relay 1, which is our instantiation of the overcurrent relay, the curve type equals 2. If radio button 2 is checked, which is very inverse, the curve type is 3. And if radio button 3 is checked, curve type is 4, or extremely inverse. So that's just setting up the relay characteristics. And we continue with that. Relay 1 pickup amps. We're taking what it's specified in the UI. Time dial, we're doing the same thing, convert to double, and setting the relay 1 time dial. And we're also doing what we talked about before with our picture box. We are setting the appropriate image down here to show that the breaker is starting off closed. And again, we did another video on picture boxes, how you can do that. So we're just setting that up, and we're setting up the DFR minimum pickup is the same value that we have for the relay minimum pickup. So we're just grabbing that text box, convert to double, and setting that. And then we're enabling the timer. Since we're starting the simulation, we're enabling the timer. Now down here, all we're doing is we're enabling and disabling buttons to make it a little bit cleaner. So after we've started this, we've started the simulation, and all the control goes to this timer 1 tick. And again, this is what does all the work. So we'll go through this, and there's really not a lot to it. It sets the SCADA simulation time seconds equal to the previous time seconds, which starts off at 0. And then we are converting to double the timer interval, in our case 100 milliseconds. Divide that by 1,000 to give you seconds, and we're adding that. So each timer tick, we're incrementing the sim time in seconds based on this timer tick, and we're just incrementing that. So now we've got the new simulation time in seconds, and then we are reading in the current from the Arduino, and there's a method. We'll show you how to do that. It's pretty straightforward. And we have a double raw amps. Now, I mentioned before that if we're reading every 1/10 of a second, we're going to get some bouncing around of these readings from the Arduino. So what I'm doing is I am filtering that raw amps using a low-pass filter. And we talked about this in other videos. We're saying the filtered amps, and what we're doing is we're saying we're going to take 80% of the previous filtered amps plus 20% of the new raw amps to get our actual filtered amps. And you can change these values as long as they add up to 1. You can say 90% plus 10%, depending on how much this thing is bouncing around. So we're going to use 80% of the old value plus 20% of the new value to give us the actual amps that we're going to use for both the overcurrent relay and the DFR. So we're setting the SCADA.line amps equal to that filtered amps. And then we're setting the old equal to this new filtered amp so we can use it in the next step. So here we're just filtering the input current. And then now that we've got that, we can call the relay one overcurrent detector, which we talked about before, which takes that SCADA line amps and determines, hey, is it too much? Do I need to start the timer and trip or not? And then we're going to, once we've done that, we're going to do the same for the DFR. We've got the overcurrent detector method, and it's going to say, hey, is the current above my set point? If so, I'm going to start recording the data as we talked about before. So that's basically all we're doing each time step. We are just incrementing the time step, reading from the Arduino, filtering it a bit, and then running the overcurrent detectors in both devices, the relay and the DFR, to let them do their thing. Now, if the fault detector is picked up, so if the relay has said, hey, this current is above my normal value, and the fault detector is picked up, the first time this thing picks up, we need to do some stuff. So this if statement is executed once when the fault detector initially picks up, then fault started is toggled so it doesn't happen again. So we only want to do this once. If fault started is false and the fault detector is picked up, we now set the fault started as true, and we're saying the fault start time, the whole purpose of this is to figure out what the fault start time in the simulation is, and we're going to say that's equal to the sim time in seconds. So this just helps us figure out at what time did the fault start. Also, if the fault detector is picked up, we want to flash this fault indicator. All right, this fault indicator, which is a picture box, and then we're going to flash it by changing the image. So we're going to flash the fault indicator, and then we're going to output to LCD. Now, this LCD, the output, depends on whether, if the fault's not picked up, I just want to have the amps here. However, if there's a fault detector picked up, I want to put some data about the relay timing out and how much time is remaining and so forth. So I have this output to LCD method we'll talk about, and we'll feed it a value saying what is the status of the relay, which defines what I want on the LCD. So if the fault detector is picked up, I figure out what the fault start time is, and then I flash the fault indicator and then output to the LCD. Now, if the relay 1 fault detector is picked up is false, which means there's no fault detector picked up, and the relay 1 hasn't tripped, I just want to output the normal amps. So I feed it a 1, and it will just tell me what the amps is on the LCD. Now, if the relay has tripped, we're going to update the UI and save to CSV. And basically what we're doing is we're saying, okay, the relay 1 fault duration is the SCADA sim time in seconds minus the fault start time. So if relay 1 is tripped and the trip out is false, we want to figure out what the fault duration is, and it's just this value. And then we're going to update the UI controls if the relay has tripped. And we are setting the picture box 1 image to status lights open, and picture box 2 image to the fault is on, and DFR enabled is true, and back color is orange. So this is basically after the relay has tripped, we want to set up the UI so that it looks like the relay has tripped. And then we're saying trip output equals true, and then timer 1 enabled is false, so we disable the timer because we've tripped. And then we're going to output to LCD 3, which means output to LCD corresponding to the relay has tripped, and then we're going to do save to CSV. So that's basically it with the timer tick. Let's look at the methods that we're running, the output to LCD and save to CSV methods. So we'll go up to our methods, and you can see we've got 4 methods that we're going to be using we've talked about. Read amps Arduino, we are basically sending an L command, as in log, and we've talked about this in previous videos. We've got the Arduino set up. When it receives an L, it's going to send back a reading from the analog 0 input where we've got the current from the current sensor coming in. So we send an L. The Arduino says, oh, I got an L. I need to read from A0 and send it over the COM port. So we do Arduino port read line, and that is a string. And then we are converting that to double, and that's the latest reading double. And then we're converting that to volts by saying, what's that latest reading double, which is going to be 0 to 1023, where 1023 equals 5.18 amps. And we're going to divide that out and multiply times the Arduino VREF, which is 5.18, and that gives us the actual voltage reading. And then to convert that to amps, we take the volts minus 2.5. Again, the current sensor gives 2.5 volts out for a reading of 0 amps. So we take the volts minus 2.5 multiplied times sensor amps per volt, in our case 10 amps per volt, and that will give us a amp reading based on what we got from the Arduino, and then we just return that amps. Output to LCD. We've got basically 3 formats we want the LCD to show. If the relay has timed out and tripped, format 3 is where we set up the color black, what the font is, and then append text. And again, I did a video on rich text boxes. I encourage you to look at that. So we set up the amp reading in black, and then we set up a trip time after the relay has tripped. We set that up color red, and we set up an 18 font and trip time. If the format is 2, which means it's timing, it hasn't tripped out yet, but there's a fault and it's timing, we set it up with this format and we give it a time remaining. Else, if it's just an amp reading, nothing is picked up, we set it with black and we just give it the amps. Flash fault indicator. This is just going to change the image in this picture box 2, which is this picture box right here that has the flashing light. What it does is every 3 time steps in our case, it's going to change the image in that picture box. One is a bright orange and one is a dull red. So it will flash on and off every 3 time steps. So if flash delay is greater than 3, if flash on equals true, the image is fault on, else it's fault off, which is a dark red. So every 3 time steps we flip whether it's flash on or flash off, and then flash delay is 0, so we start incrementing again flash delay. So you can go through this and logic it out, but basically it's going to change the image every 3 time steps. And then the last one is save to CSV. We've talked about this in many other videos. First we delete the file if it exists. If file exists, and then we do a delete. And then for all of the values in this DFR class, all of these time and amps values, we're going to step through and then write them to our file, which is a time, comma, and an amps value. Pretty straightforward. So now the last thing we need to look at is when we do this DFR, when we've had a fault, the relay has tripped, and it's going to show this DFR chart. Now again, we did another video on multiple forms and passing data to a chart, so this should be familiar to you. But basically we are instantiating our form 2, which is this guy, when we hit this DFR button, which is this button here. We are instantiating that chart, we're calling it chart form, and then we are calling a method in form 2 code, which is right here, we'll talk about. And it is basically passing the DFR time and amps to that other form and then showing the chart. So now here is our form 2 code, and really it's just keeping a local time and amps list that are going to be filled based on what's in the DFR time and amps. We're just going to send it over to form 2 when we want to chart it. And then the rest of this is basically setting up this chart. We're saying a line chart with a line width of 3, and we're setting up the format and line color for the major and minor grid. You can just copy that if you want or do however you want. And then here is the method that receives the data from this DFR, these time in amps, and all it does is it receives those values and sets them equal to the local values, and then data binds those local values to the chart, and that will plot the chart. So that's about it. You've seen most of this stuff already in other videos, but that's about it for this one. In the future, we're going to look at some DC non-protective relays, more control relays. And I encourage you to look at those. If you like any of these videos, please hit the like button, subscribe, hit the bell notifications. But most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.